This Prelab video is for the determination of the molar mass of a gas using the Dumas method. We're going to be using the ideal gas law to calculate this molar mass. Now, molar mass has two parts, mass and moles, so it's grams per mole. The mass will be measured on a balance, and I will describe that procedure in a minute. And moles will be calculated using the ideal gas law, which is PV equals nRT. N represents moles, so we'll be solving for moles, which means we need pressure, volume, R, gas constant, as well as temperature. This Dumas method procedure, I found a video on YouTube that shows this procedure quite well. There's a couple differences in what we're doing, but very, very few. Where they use a copper wire to hold on their aluminum foil, we'll be using a rubber band. But everything else is pretty close.
In the Dumas method of determining the molar mass of a volatile liquid, we'll start out massing an empty 125 milliliter Erlenmeyer flask, a small piece of aluminum foil, and a small piece of copper wire. We will then add approximately 5 milliliters of the unknown liquid. We will cover the mouth of the flask with the aluminum foil. We will use the copper wire to hold the aluminum foil in place. We will place a small pinhole in the top of the aluminum foil. We immerse the flask in a beaker of boiling water. The liquid inside the Erlenmeyer starts to boil and vaporizes. As it vaporizes, it pushes air out of the pinhole. Eventually, all the liquid vaporizes and the flask is filled with just enough vapor to fill the flask at the temperature of the boiling water. Once the liquid has completely vaporized and the vapor has reached the temperature of the water bath, we will remove the flask from the water bath. The vapor inside the flask will condense to a liquid. When the flask is cooled to room temperature, the liquid that has condensed was the amount of vapor that would fill the flask at the temperature of the boiling water bath. We will now mass the flask, the liquid, the aluminum foil, and the copper wire. Since we know the mass of the empty flask, aluminum foil, and copper wire, we can get the mass of the liquid. We will determine the volume of the flask, which is also the volume which the vapor occupied at the temperature of the boiling water bath. We'll remove the copper wire and the aluminum foil. We will fill the flask completely with water, and we will pour the water into a graduated cylinder. We will record the volume of the water.
So let's go through some of the calculations that you'll be doing. So recall, we're going to be using the ideal gas law to solve for moles. We need the pressure. This is the atmospheric pressure that we read right off the barometer. Your instructor will either provide that for you or help you read the barometer. It's important to change the units from millimeters of mercury into atmospheres because we're using the ideal gas law constant, which contains atmospheres for the pressure component. We also need to change volume of your flask in liters into liters. We're going to be solving for N. Here's the constant. And you'll be recording the temperature of your water bath, which will also be the temperature of your vapor that was contained within that water bath. You need to convert that to Kelvin and just solve for moles. Now we need to calculate grams per mole. Once you have two trials that agree within about 10 grams per mole, you will average those two trials and make sure you report that in your conclusion. That's the point of the lab. You want to answer your purpose in your conclusion. So unknown letter B, for example, has a molar mass of 122.4 grams per mole, whatever your average is. Please take a look in the beginning of your manual and search for the How to Write a Lab Report section. Read that very carefully. Look through that every time you write a lab report, and you'll make sure that you have all of the sections covered. And that concludes this video.